Guys, so in this video, I want to talk about the proof of parallelogram law. Okay, so I think everyone knows about what the parallelogram is. So basically, you have like the two lines which are parallel to each other, and this guy these two lines also parallel, and let's call it A, B, C, D. Okay, and I told this straight line is the BD, and then this is AC. Okay, so the theorem basically it has 2ab squared. So basically this guy squared plus 2bc squared, this guy squared will be ac squared plus bd squared. Okay, so or basically if you square the four sides and the sum of them, then it will become the diagonal, the square of the diagonal, and then you sum two of it. Okay, and this theorem is very simple. So let's do not waste time and quickly dive in the proof. Okay, so the easy idea is that let's call this guy alpha. Okay. So the first equation from the cosine law, right? Everybody knows about the cosine law. It's basically this BD squared will be a squared plus b squared. Okay, let's give some notation. Right, let's say this is b, b, a. Okay, so a squared plus b squared minus 2ab cosine alpha, right, will be bd squared. And how about ac squared, right? So ac squared is a squared plus b squared. So remember these two are parallel, right? So this guy is pi minus alpha, so it's 2ab plus cosine alpha. Originally it's minus cosine pi minus, so the key is this. Okay, so sum of it, so bd squared plus ac squared will be 2a squared plus b squared, which is exactly 2ab squared plus 2bc squared. Okay, so this is the proof. Okay, so this is the usual planar geometry, right? And we can generalize into the linear algebra that people talk is the inner product space. Okay, so inner product space is basically let's suppose that you have a vector space V, right? And then there's an inner product, right? So everybody knows about what inner product is. So give it to V, then you can give the underlying field K. So usually K can be choose C or R. Okay, and the inner product space has various property, and you can define a length square will be just the inner products of the same vector. So this is the norm square. Okay, so inner product space will naturally be a norm space, and then there is a generalization. I think it's very easy that you just give guys that you two sum of square, right? So if this is x, this is y, right? And then this guy is x plus y, and then this guy is x minus y. Oh, so this guy is x minus y. So this is x plus y length square minus plus x minus y square. So this is the generalization of this law in the inner product space. So let's quickly see a proof. Okay, so proof is very easy, right? So just follow the definition. So we know that x plus y squared is basically x plus y. So it's inner product is linear, right? So it's xx plus xy plus yx plus yy. And the same, this is x minus y squared. It's basically the same, x minus y. So it's xx minus xy minus yx plus yy, right? So the idea is that you just add these two. So you get x plus y squared plus x minus y squared equals to, let's say, xx, y, and add 2, right? So this is by definition. Okay, so that's the proof. Okay, so yeah, I think that's basically the idea. Okay, so basically you can this works for any inner product space, and then if you learn about the further analysis or something other like the functional analysis, then you will keep seeing that this formula. Also, this formula is famous in the Hilbert space. Right, so in the Hilbert space is the complex it's also a complex inner product space. So I think that's it. And next time we will talk about the polarization identity, which is very close to this parallelogram law. Okay, and let's see. Let's maybe talk about one application. So I just want to make a one application. Right, so this basically is planar geometry section. So I don't want to talk about that for analysis or functional analysis or some kind of not related to planar geometry. Okay, so the idea is that I want to see that suppose you have a triangle and you cut the midpoint here and you connect this guy, right? So let's call it D. Let's call it D, and I want to ask what is the length of AD if this is a midline. Okay. So in general, you need to use the cosine law to find it, right? But now we don't have to, right? Because we can connect it make it into the this parallelogram. Okay, so now we know it. So by the law, right, we get a 2b squared plus c squared will equals to this guy a squared plus 2ad squared, right? So this is the parallelogram law. Okay. Oh, where is it? Okay, so now we can solve AD. So we get the 4ad squared is basically 2b squared plus c squared minus a squared. So the AD squared, let's quickly get. So AD will be a half 2b squared plus 2c squared minus a squared. Okay, so let's quickly see a case. If we are working in an equilateral triangle, then the AD will be half 3a squared. So it's square root of 3 divided by 2 times a, which is exactly this guy. Okay, so this is the one easy generalization of the midpoint that this midpoint length. Basically, you can use this parallelogram law to derive it. And also, I just talked about some inner product space. If you know a bit of linear algebra, but it's fine if you don't know that. Okay, so I will see you guys in the next video. Be sure to subscribe to my channel. Thanks.